Here we will see what is histogram equalization. So histogram is a graphical representation of the input image where the x-axis represent the intensity levels, that is levels corresponding to the input image will be plotted along the x-axis, and the y-axis represent the number of pixels corresponding to the input image. So that is corresponding to the input image which represents a particular intensity level. So if you have two pixels corresponding to the intensity level 0, the histogram will represent that intensity level like this. So there is another process that is called histogram stretching. The difference between histogram stretching and histogram equalization is that in case of stretching, the process stretches the intensity levels. That is, if you have only 2 to 7 intensity level in your input image, you can stretch this to 0 to 7 without changing the count of the pixels. That is, in histogram stretching, there is no change in the shape of the histogram. But in case of histogram equalization, the shape of the histogram changes. That is the difference between stretching and equalization. So, equalization is a process that attempts to spread out the gray levels in an image so that they are evenly distributed across their range. That is, the count is evenly distributed. It reassigns the brightness value of the pixels based on the image histogram, and the histogram of the resultant image is as flat as possible. That is, it will remain more or less like this. So it is almost flat. So provides a more visually pleasing results across a wide range of images. So these are the advantages of performing a histogram equalization in the input image. That is, overall it enhances the image. So it is an image enhancement technique. So this is an example of histogram equalization. This is the image that is prior to equalization, and see the histogram that corresponds to this image. We can see that the histogram shows more pixels in this range of intensity levels and less pixels in this range. That is, it is clustered towards this range. But if we perform the histogram equalization, we can see that we can have same number of pixels in most of the intensity levels. So if we're doing like this, and if we try to generate the image again, you can see that it is more clear compared to the old image. So this is the advantage of histogram equalization. So there are some steps in performing histogram equalization. The first one is finding the running sum of histogram values. Normalize the values from step 1, that is in the previous step, by dividing the total number of pixels. Then multiply the values from step 2 by the maximum gray level value, and then perform the rounding off. Then map the gray level value to the results from step 3 using one-to-one correspondences. So these are the 4 steps, and it is the most important process that can be performed very simply in a spatial domain image. So we will see these steps with the help of an example. So this is the image segment. So suppose this is the image segment. So you can see that this contains 5 by 5 pixels. That is, this is an image of size 5 by 5. And represent from this, we can see that the intensity value ranges from 0 to 7. Okay, so there are 8, that is 2 raised to 3 pixels. 3-bit image is this, and you will have 2 raised to 3 gray levels that ranges from 0 to 7. So this is a image, and this is the corresponding count, that is the frequency is given in this table corresponding to each intensity level. So you can see that there is no pixels corresponding to 0, so the count is 0. No pixel corresponding to 1, so count is 1. No pixel corresponding to 2, that is count is 0. So for 0, 1 and 2 gray levels, the number of pixels is 0. But if you see 3, there are 6 pixels that correspond to gray level 3, then 14 pixels corresponding to gray level 4, 5 pixels corresponding to gray level 5, then 6 and 7, there are no pixels in the input image. So you can see that the maximum value in the given image is found to be 5. So the 5 is the maximum intensity level in the input image. And we can see there are 8 possible gray levels that ranges from 0 to 7. So the first step in histogram equalization is compute the running sum of histogram values. So running sum of histogram value means finding the cumulative frequency distribution, that is CFD. So in the table you can add one more row, that is which represent cumulative frequency distribution. So here it is 0, 0, 0, 6. Then what about the cumulative distribution here? It is 14 plus 6. It is 14 plus 6, that is 20. And here it is 20 plus 5, that is 25. Then here it is 25 plus 0, that is 25. And here it is 25 plus 0, that is 25. That is cumulative frequency distribution is found out by adding the previous CFD with the current number of pixels, that is 6 plus 14, that gives 20. So that is given in like this. The flow is like this in calculating CFD, that is 6 plus 14 gives 20, 20 plus 5 will gives 25, 25 plus 0 will give 25, 25 plus 0 will give 25. So this is the first step, that is the computing running sum of histogram value in the input image. Then the next step is dividing the running sum obtained by the total number of pixels. So what are the total number of pixels? Here the total number of pixels is 25. That is, it is a 5 by 5 image. So 5 by 5 means 25. So 25 pixels are there in the input image. So divide each CFD with the total number of pixels in the input image. Divide it with 25. Then the next step is multiply the value by the maximum gray level. So we have seen that the maximum gray level is 7 because there are the intensity values which ranges from 0 to 7 in the input image. So the maximum value is 7. So multiply it with 7. You will get these values and you have to perform the rounding off. So what you have to do is 6 by 25 into 7, and then it is rounded off to get this value 2. Okay. Then next is you have to map the gray level to the results, that is you obtain from step 3 using one-to-one correspondence. So in the previous step you have seen that corresponding to the initial gray level you have obtained a new gray level values. How will you map this to this one? So you can see 4, 4, 4, 4, 4 is the first row in the input image, which is to be mapped to 6. That is, the 4 in the input image is represented by the 6 in the output image for histogram equalization. So you have to replace all this 4 this with the 6. So here also you have to replace with the value 6. Then here also you have to replace with the value 6. Then here also you have to replace with the value 6. So the next input level in the input gray level in the image is 3. That is corresponding to 3. You have to replace it with 2. So 3 to be replaced with 2 here, 2 here, 2 here, 2 here, then 2 here, then 2 here. Then the next gray level is 5. So corresponding to 5, you have 7. So all these 3 values will be replaced by 7. Then here also it is 5, you will get 7. So this is how histogram equalization will be performed. So this is the input image and this is the histogram equalized image.